Okay, how's it going? Hope everyone has been staying safe, getting some new hobbies, spending some quality time with your family slash Netflix. I will delay the test by a day, so we'll have it due on Wednesday because I could not get this thing to load up yesterday, the thing I used to record. Um, so here we go. I'm going to go through all the problems. Test gonna be just like this. So if you got any questions, fast forward, rewind, do what you need to do, and then ask me some questions if the stuff doesn't make sense. So graphing inequalities, solving absolute values, and graphing absolute value inequalities, basically putting the first two things together. First thing you always want to do is either get the absolute value by itself or the variables on one side. So on the first one, trying to move all the variables to the side that has more already. So we're going to subtract x on both sides on this, and we'll have 2x is greater than 8. Divide by 2 on both sides, and we will have x is greater than 4. That's it. Bada bing, bada boom. Or it's just like an equal sign, unless you are multiplying or dividing by a negative number, in which case you will need to flip the inequality. So this becomes this, or this becomes this, right? That's only if you multiply or divide by a negative on both sides. Number 2, I'm going to distribute first. So distribute this. We got negative 4x minus 20 is less than or equal to 2x plus 6. And this time I'm actually going to do it just so you can see. I'm going to move the variables over to the left side, subtract 2x on both sides. Let's change some colors so we see what we're doing. Subtract 2x on both sides. And I'm going to move my 20 over to the other side by adding. So we've got negative 6x is less than or equal to 26. Right, these combine to be 26. This combines to be negative 6, and then I need to divide both sides by negative 6. And that's exactly what I was just talking about. If we multiply or divide by a negative, my inequality is going to change. So we'll have x is greater than or equal to, these are both divisible by 2, right? So this becomes 13, negative 13 over 3. Final answer. All right, so if you multiply or divide by a negative, we see my inequality is going to flip. The net less than or equal to becomes greater than or equal to. On the absolute value problems, remember anything you put in here becomes positive. So you got to make sure that what we do is possible, right? We want to be careful of negatives on the other side because that would be no solution. But whatever I put in here is going to be positive. So there's actually going to be two different ways. We're always going to split this up. One way is just regular, and the other way is all this stuff on the bars on the inside stays the same, and what's on the other side changes signs. It's going to become the opposite sign. So if I plugged in 3, make 3 positive, it's 3. If I plug in negative 3, make negative 3 positive, it's also 3. So both of these solutions would be correct. Similar number 4. Got split up. One way is just as it is. So just x plus 4 equals 5. The other way, x plus 4 stays the same. It's the 5 that changes. Negative 5. And when I subtract 4 on both sides, we got two answers. This one will be 5 minus 4, x equals 1. And the other one, negative 5 minus 4 is negative 9. Right, and we can always check these by plugging them back in. If you plug in 1, 1 plus 4 is 5. Make 5 positive, it's good. This one, negative 9 plus 4 is negative 5. Make it positive, it's 5. We're good. Number 5. We do have to get the bars by themselves first, so I'm going to subtract 1 on both sides. And then I'm going to need to divide by 2. So these cancel out. I'm left with just the bars now. X minus 3, absolute value of x minus 3 equals 6 divided by 2 is 3. And now I split it up. So one way is just as it is, x minus 3 equals 3. And the other way, x minus 3 equals negative 3. So what's on the inside is always staying the same. This x minus 3 stays the same on both the splits. It's what's on the right side that's going to change signs. And now I just solved this by subtracting 3 on both sides. Sorry, adding 3 on both sides. And we get two answers, x equals 6 and x equals 0. Okay, number 6. This is one of the trick problems. Might not look at first, but we got to get the absolute value by itself. So when we subtract 5 on both sides, we get absolute value of 2x minus 1 equals -3. You got to think about it. This makes it positive, no matter what. Everything that goes in here becomes positive. So I want to know when is a positive number equal to a negative number. It's literally impossible. So if you get the absolute value by itself equal to a negative number, this is no solution. Nothing we could put inside would make it negative because the absolute value, by definition, makes it positive. So this is impossible. Absolute value cannot be equal to a negative number. Number 7, trying to get the bars by themselves. We just got a few things wrong. We got to do one step at a time. I'm going to subtract 3 and then multiply by 4. And then please do what I asked. Okay, subtract 3. Come on, what's it doing? Y'all see this? Subtract 3 times 4 and then divide by 3. So subtract 3 on both sides. And we've got 3, 2x plus 5 bars over 4 equals 0. Multiply both sides by 4, that's going to be 0. And then divide both sides by 3, that's also going to be 0. So I'm going to be left with the absolute value of 2x plus 5 equals 0. I'm going to split it up. One way is just as it is. And think about it. What if I did the other way? If I made this the opposite, negative. Negative 0 is just 0. So this case, there's only going to be one solution, because if I split it up over here, it would be the exact same thing. All I got to do is subtract 5 on both sides. Got 2x equals 5, and then divide by 2 on both sides. There's only one solution of this one. -5 over 2. It's a 5. Okay, graphing. So remember, we've got open circles if there's no or equal to, and closed circles if it looks something like this, where it's less than or equal to or greater than or equal to. So we've just got a number line like this. Make sure you put 0 up there somewhere in the number that you want. This is an open circle. And since x is bigger, that means I'm going to the right. So x is going to the right of 3. It's greater than 3. That's it. All right. Up here. Move my face. All right, we're going to try and get the x by itself. So subtract 5 on both sides. We've got 2x is less than or equal to -2. Divide both sides by 2, and we have x is less than or equal to -1. Less than or equal to means that I'm going to have a solid dot. So I put my number, I put 0. It's going to be a solid dot because it's or equal to. I got this line underneath. So put that at the number I want. And less than or equal to x is smaller, means I'm going to the left. We're always graphing x. So if x is smaller, we're going to the left. If it's bigger, we're going to the right. We're kind of combining two things. On number 10, we're doing the absolute value and we're doing the inequality, and we're going to graph it. So it's by itself, so I can split it up. One way is x plus 5 is greater than 2. And here's the other big change. It's still x plus 5, but now two things happen. Yes, this becomes a -2, but I also have to flip the inequality. So on the side where I make the right side negative, this inequality is going to flip and become less than. That's every single time. So this flips and this changes signs every single time. So I'm going to solve for x, subtract 5 on both sides. We got x is greater than -3. Subtract 5 on both sides, and we've got x is less than -7. And I'm just going to put both of these spots up on my graph. So we've got -7, -3. Make sure you tell me where 0 is at. This time I've got open circles because it's not or equal to. Open circle, open circle. X is bigger than -3. That means I'm going to the right of -3. And this one says x is less than -7. Less than is going to the left. Final answer right here. It's like two graphs in one, basically. All right, just a couple left. We got to be careful. If there's negatives right here, think about this. What's this going to do? Absolute value. It makes it positive, right? So when is a positive number bigger than a negative number. When is a positive number bigger than a negative? Always. This will always be true. Whatever you put in here, it makes it positive. Positive is always bigger than a negative, so the answer is always. If you want to graph it, the graph just looks like this, everything. And similarly on number 12, when is a positive number? Remember, that's what absolute value does, makes it positive. When is a positive number going to be less than a negative number? Well, that never happens, right? This is impossible. If it's positive, it cannot be less than a negative number. So this is no solution. And the last two are the most interesting. We need to get the absolute value by itself. So I'm going to subtract 3 on both sides. We got 2 absolute value of 3x plus 4 is greater than or equal to 6. Got to keep getting this by itself. The opposite of times 2 is divide by 2 on both sides. So those cancel out, and we've got absolute value of 3x plus 4 is greater than or equal to 3. And now I can make my split. One way is just going to be as it is. So we've got 3x plus 4 is greater than or equal to 3. And the other way, remember, we got two things going on. We need to flip the inequality and change the sign of this. And then I'm just going to solve from here. So two things. You flip the inequality and you change the sign every single time you've got an absolute value inequality. So I'm going to just subtract 4 and then divide by 3 on both sides. Subtract 4 on both sides and we get 1. Divide by 3 and we get negative 1, 3. That's fine to get a fraction. Over here, subtract 4 and we've got 3x less than or equal to negative 7. Divide by 3 and we've got x is less than or equal to negative 7 over 3. It's fine that it's a fraction. We'll just leave it like that. And we're going to put it on a graph. We got some closed circles, right, because it's greater than or equal to. We'll put my numbers up here. Make sure you put 0. And so we got some closed circles at negative 7 over 3 and negative 1 over 3. X is bigger than negative 1 over 3. That means I'm going to the right. And x is smaller than or equal to negative 7 over 3. That means I'm going to the left. Final answer right here. And the last problem, trying to make sure you totally understand what's going on. So it's a little bit complicated, but that's fine. Got to subtract 2 on both sides, then times 4, then divide by 3. So I subtract 2 on both sides. Then I'm going to do times 4 on both sides. That's going to make this a 24. And then divide both sides by negative 3. So what's going to happen when we divide by a negative? The inequality is going to flip. So we've got 2x minus 5 in the absolute value is now greater than negative 8. And when is a positive number bigger than a negative number? That's going to be always. So hope you got something out of this. I will push the test back to be due on Wednesday. If you got any questions, you need to send me an email and we can work it out. Feel free to rewind the video, go to the problems that you need. Yeah, me and Mr. Powers are here to help. So stay safe and I'll see y'all soon. Bye-bye.